So welcome everyone to today's session. Our topic for today will be functions. So if everyone is ready to begin, let's get started. Okay, so before we get started, I want to do a quick recap on functions itself. So let's get started with the first function. As we all know, the easiest function to deal with is the linear function, right? Okay, so with the linear function, we know that if m, which represents the gradient, so if m is greater than 0, our function will look something like this. Okay, so it will be an increasing function. And if m, which is the gradient, is less than 0, meaning negative, we will then have our function looking something like this. Which is our negative gradient. Okay, so from there we can calculate our gradient formula, which is m is equal to y2 minus y1 all over x2 minus x1. Okay, so this formula is very basic. We learned it, I think, maybe in grade 8, so we should all know that by now. Another way of calculating gradient is this formula right here. M is equal to tan theta. Guys, whoever's joining the meeting, could you guys please mute your mics? It's very disruptive. Okay, so back to the session now. So regarding gradient, we also know that parallel lines have equal gradients. So for example, if line A, B is parallel to line C, D, their gradient would be equal. So the gradient of line A, B is equal to the gradient of line CD. And if the lines are perpendicular, then their gradients would, when you multiply the gradients, they would be equal to 190 degrees. Sorry, they would be equal to -1. So perpendicular lines meet at 90 degrees. So let's make this a B and the C D. So the gradient of line AB times the gradient of line CD is then equal to -1. And then we know that those two lines are perpendicular. And now with the equations of a straight line, we've got two equations of a straight line. So our first equation of a straight line is y is equal to mx plus c. As we know, the m stands for gradient, the y for our y coordinate, the x for our x coordinate, and the c represents our y intercept. And our y-intercept is the line at which the graph cuts the y-axis. So if we've got a straight line like this, our y-intercept would then be this point here, where our line is actually cutting the y-axis. And whenever a line cuts the y-axis, we know that the x value would always be 0. Okay? Our second equation of a line is y minus y1, which is equal to m, open a bracket, x minus x1. So in order to calculate an equation of a line using this equation, we need to first calculate our gradient. And after we calculate our gradient, we need to choose any point on that line, and that would be our x1 value and our y1 value. Okay, so I think that's about it for straight lines. Let's move on to the next function. So our next function is our hyperbolic function, right? Sorry, let's go to our quadratic function. Okay, so when dealing with our quadratic function, so we we can also call this the parabolic function. Okay, so first things first, whenever the value of a is greater than 0, whenever the value of a is greater than 0, our quadratic or our parabolic function will always have a smiley face and will look something like this. And whenever our value of a is less than 0, meaning negative, our quadratic function will have a sad face, such as this. Okay, so when dealing with a quadratic function, we've actually got 3 basic formulas or forms that we can use. So the first one is y is equal to ax squared plus bx plus c, which is the standard form. This is the standard form. Our second one is y is equal to a, open a bracket, x minus p squared plus q, and this is our turning point form. Our third form is our x-intercept form, which is a, open a bracket, x minus x1, close the bracket, open a new bracket, x minus x2. So as you remember from previous grades, our x-intercept is actually when our graph cuts the x-axis, okay? So for example, if we've got a line graph like this, well, actually let's make it a quadratic graph since we're dealing with quadratic equations. So if we've got this quadratic graph over here, this point here would be our x-intercept, and this point here would also be our x-intercept. And the point right at the bottom would be our y-intercept. So wherever the graph cuts the x-intercept, y is 0, and wherever the graph cuts the x-axis, y is 0, and wherever the graph cuts the y-axis, our x value is 0. Okay. Next, our equation for calculating a turning point. So our turning point equation is always represented like this. X of t is equal to negative b over 2a. And that's how we would find our x value of our turning point. Now to find our y value of our turning point, all we do is we take our x value and substitute it back into the original equation. So y would be equal to a, and then our x value would be negative b over 2a squared plus b, and our x value, which is negative b over 2a plus c. Okay. Then when dealing with our domain and range for a quadratic or parabolic graph, Okay, so when dealing with domain and range, let's first deal with domain, right? So when we deal with domain for a quadratic graph, our domain is always equal to x, an element of real numbers, if the graph is not restricted. Because as you can see, when we have our graph, right? So this would then be our x-axis and our y-axis. So this graph continues. That's what the arrows represent. It just represents continuation. So our graph would continue and continue and continue until infinity in the negative direction, and continue in the positive infinity direction. That's why we represent it like this: x, an element of real numbers. Now when dealing with our range is a bit different compared to our domain. So where domain represents the x values that the graph touches, and range represents the y values that the graph would touch. So as you can see, our range is a bit restricted when we deal with a quadratic graph. So for example, when a is positive, when a is greater than 0, our range for our quadratic graph would then be y greater than or equal to the y value of the turning point. Because as you can see, all the y values that the graph touches would be from this point over here, which is the y value of the turning point, all the way upwards until infinity, because that's all the y values that the graph touches. Whereas when our graph is a less than 0, so now our a value is then negative, which means our graph would have a sad face. Okay, so our range would then actually be y less than or equal to the y value of the turning point. So as you can see, it would be this point over here, and then all those values less than that point as the graph touches all those y values. You can never say that the graph would be these values up here, because the graph doesn't touch these values. And with regard to this graph, it never touches these values over here. So when a is positive, your range is always y greater than or equal to all the y value of the turning point. When your graph is less than 0, your range is always all the values of y less than your y value of your turning point. Okay, so I think that's about it for quadratic or parabolic equations. Let's jump to hyperbolic functions. Okay, so hyperbolic functions, right? When dealing with hyperbolic functions, we know that our equation for, or you can say formula for hyperbolic function is always y is equal to a over x minus p plus q. Our asymptotes would then be x is equal to p, because which is actually our, what's going on? Okay, so this is actually our vertical asymptote. It's our vertical asymptote, and we have y is equal to q, which is actually our horizontal asymptote. Okay, so if we have our axis like this, our vertical asymptote would cut our x-axis. So this would be our vertical asymptote. X is equal to p, and this would be our horizontal asymptote of y is equal to q. So as you can see, the vertical asymptote cuts the x-axis and the horizontal asymptote cuts the y-axis. Okay, so p is the vertical asymptote, but p is also the horizontal shift. So if the graph were to shift horizontally, your value of p would change. If the graph was to shift, if your graph was to shift vertically, your value of q will change, sorry. Then besides asymptotes, we've got our range. So before we go to range, actually, remember when a is greater than 0, our hyperbolic function would be like this in quadrant 1 and quadrant 3. When a is less than 0, our hyperbolic function will occupy the space in quadrant 2 and quadrant 4. And when dealing with domain and range, so our domain would always be, for a quadratic function, our domain is always x, an element of real numbers, where x is not equal to p. And for range, our range would always be y, an element of real numbers, where y is not equal to q. Yeah, should be about it for. Oh, one more thing, your axis of symmetry. So a hyperbolic function has two axes of symmetry. It's got the positive gradient axis of symmetry, and it's got the negative gradient axis of symmetry. So the positive gradient is y is equal to x plus c, and the negative gradient axis of symmetry is y is equal to negative x plus c. Okay. So next function will then be our exponential function. Once we're done recapping our functions, we'll go through some questions from past papers. Okay, so when dealing with our exponential function, a greater than 0, and the function will look like this. This will be an increasing function because as the value of x gets bigger, so x values increase this way, our y values also increase. So this is an increasing function. And when a is less than 0, our function would then look like this. So as you can see here, as the x values are getting bigger, our y values are decreasing. So this is a decreasing function. Okay. So the formula for an exponential function is y is equal to a times b x plus p plus q. So an exponential function has only got one asymptote. The asymptote is q. And q, as you remember from before, is the q is the horizontal asymptote. Q is also the vertical shift, and P is also the horizontal shift. And what else? The only line of symmetry that an exponential function has is actually our horizontal asymptote. Yeah, that's about it actually. Oh yeah, domain and range, sorry, I forgot about that. So our domain, so we can represent our domain of a of an exponential function as x, an element of real numbers, as an exponential function really covers all the x values, whether it's a greater than 0 or even a less than 0. But our range is actually a bit different in an exponential function. So when we deal with range in an exponential function, we have our function like this. Function f. So our domain is, our range is actually y greater than q. Because remember, q is our horizontal asymptote. So for example, if our horizontal asymptote is y is equal to 1, so our range would then be y greater than 1. Or if we had a function like this, and let's call this function g. So our range of g would actually be y less than our q value. And if q was equal to -1, our range would then be y less than -1. Okay, so I think that's enough recapping. Let's get straight into questions. Is the question visible for everyone? Okay, cool. So let's get started. I think this one is from 2015. Welcome. Okay, so let's get started with the question. So the question says, write down the equation of the asymptote of f. So as we can see, f of x is an exponential function, right? We can see our y, it's too big. So we can see our y is equal to a times b to the power x plus p plus q. And here we can see our f of x as f of x. So we can see our a value is 1 times 2 to the power x plus our p value is 1 minus 8. And our q value is 8. So to answer the first question, question 4.1, we can see that the asymptote of f is y is equal to negative 8. Because I remember previously I told you that the asymptote of an exponential function is the horizontal asymptote. It's only got one asymptote, which is the q value. And our q value here is negative 8. Okay. The next question is question 4.2. So 4.2 wants us to sketch. Okay, so now we've got our x-axis and our y-axis. So y and x. We can make this 2, 4, and 6. We can make this negative 2, negative 4, and negative 6, and negative 8. We can make this 2 and 4. Let's extend this a bit. So we can make this negative 2, negative 4, and negative 6. Okay. So now in order to sketch this, we need first our asymptote, which we have as y is equal to negative 8. So we're actually going to need to extend our graph a bit more. So let's be negative 8 and negative 10. Okay, so we've got our asymptote of y is equal to negative 8. The next thing we can see is that a is greater than 0. Since a is equal to 1, then we know our graph is going to look something like this. And what else can we see? Let's get our x-intercept. So in order to calculate our x-intercept, we just substitute y is equal to 0. Actually, let's not do that. What else can we do? Let's get our y-intercept when, actually let's make it an x-intercept. That would be easier to do. So our x-intercept, our graph is y is equal to 2x plus 1 minus 8. And when you have your x-intercept, your y value is equal to 0. Okay. So y is equal to 0 would then be 2 to the power x. Actually, no, we have our x-intercept. Sorry about that. No. If we just do this, it will be so much faster. Negative 8 is equal to, so make it positive 8 is equal to 2 to the power x plus 1, right? If we transpose our negative 8 to the other side, it will become positive 8. And we know that 8 can be changed into the form 2 cubed, which is then 2x plus 1. Since both our bases are the same, we can drop them, and we're left with 3 is equal to 3 is equal to x plus 1. If we transpose our 1 to the other side, the value will change, the sign will change, leaving us with 3 minus 1 is equal to x. And then we know our x value is equal to 2. So we can have our x-intercept as 2 and 0. Okay. So if our x-intercept is 2 and 0, it would be this point over here. And our y is equal to negative 8. So we'll have our asymptote line over here. Y is equal to negative 8. And we're also going to need a y-intercept actually. So to get our y-intercept, we can just say, when we're getting our y-intercept, y-intercept, so we know when we get our y-intercept, our x value is going to be 0. So to get our y-intercept, we're going to substitute 0 into x, which will be 0 plus 1 minus 8, which is then 2 to the power 1 minus 8. And we know that 2 minus 8 is actually negative 6. So our y-intercept is going to be 0 and negative 6, which is actually this point over here. X as 0, y as negative 6, which is this point over here. So when we have our function, we can just draw it like this, cutting 2, cutting negative 6, and extending all the way like this. Okay. That was question 4.2, right? Now question 4.3. So question 4.3 says the graph of G is obtained by reflecting the graph of F in the x-axis. Write down the equation of G. So in order to write down the equation of G, we need to first know that, guys, can you guys please turn down your mics when you enter? It's really distracting. Okay, let's get back to the session. Okay, so as you can see from the question, G is obtained by reflecting the graph of x in the y-axis. So we know that whenever the graph is reflected in the y-axis, the x values change. And whenever the graph is reflected in the x-axis, the y values change. Okay, so whenever a graph is reflected, it's always kind of like the opposite. So when a graph is reflected in the y-axis, the x values of that graph changes. And when a graph is reflected in the x-axis, when a graph is reflected in the y-axis, the x values change. So for this graph, we're reflecting it about the y-axis, therefore our x values are going to change. So in order to get the graph equation of g of x, we need to first change our f of x. So g of x is equal to f of x, where the x values are changing. Okay, so this shows that the graph of g of x was obtained by reflecting the graph of f of x in the y-axis. That's why the x values change. So you just put a negative sign in front of all the x values. So g of x is then 2 to the power negative x plus 1 minus 8. And that's the answer. You can also write this another way. So if you want to write it a different way, you can write it like this as well. You can actually write it as g of x is equal to, and then if you factor out the negative sign, you'll be left with x minus 1. And remember, 2 to the power negative 1, so you'll actually have it like this. 2 to the power negative 1. If you factor out the negative sign, and you'll be left with x minus 1 minus 8. And as you know, 2 to the power negative 1 is also the same as saying 1 over 2. So you'll have 1 over 2 to the power x minus 1 minus 8. Okay, so that's about it for question 4. The next question we can deal with is, let's see. Okay, for those of you that want to know what question paper this is from, I think this is also from the 2015 paper. Excuse me? I think this is from Gauteng. Majority of the question papers I do are from Gauteng. Okay. Okay, so the question says, is everyone able to see the question clearly? Okay. You guys can see it. Okay, let's just show the first part for now. Okay, so the graph of f of x is equal to negative 2x plus 18, and g of x is equal to ax squared plus bx plus c are sketched below. Points P and Q are the x-intercepts of f. Point Q and R are the x-intercepts of G, and S is the turning point of G. T is the y-intercept of both f and G. So the first questions, okay, before we go to the first question, actually, can you guys see that question, that equation f is the sad face equation because your value of a is -2. Just excuse me a moment, please. So excuse me, let me just put up this logo. Okay, so back to what we were saying. So f of x is the sad face graph, and g of x is the smiley face graph. Okay, so the first question states, write down the coordinates of t. So the coordinates of t is not actually the turning point. We're not sure if it's the turning point. Did they tell us it's the turning point? Yeah, they didn't say it's a turning point, so we can't take it as a turning point. So they say t is the y-intercept of both f and g. So when we calculate y-intercept, all we need to do is make x 0, right? So 6.1.1, calculating our y-intercept, which is when x is equal to 0. So all we need to do is substitute 0 into our equation. So f of 0 is equal to -2, 0 squared plus 18. Okay, then we know that -2 times 0 squared is still 0, and then f of 0 is therefore 18, which means our t value is then, our x value is 0 and our y value is 18, which we previously calculated. So the next question states, write down the coordinates of q. So the coordinates of q is the x-intercept of the smiley face graph of, what was it, of g. So q is the x-intercept of g, and it's also the x-intercept of f. So in order to find the x-intercept, all we can do is make y equal to 0. So 6.1.2, when finding the x-intercept, our value of y is therefore 0. So we've got y is equal to -2x squared plus 18. If ever you guys don't understand while I'm talking, you guys can just speak up and ask what you need to, okay? So y is equal to -2x squared plus 18. So when finding the x-intercept, we always make y equal to 0. So we'll have -2x squared plus 18 equal to 0. And now we can see we can take out a common factor from here, which is -2, and we would be left with x squared minus 9. Because remember, -2x squared divided by -2 is x squared, and positive 18 divided by -2 is -9, which is then, and 0 divided by -2 is still 0. So we have 0. Then we've got our factorization method. So with this, the best factorization method we can go with is the difference of two squares, because we know x squared, that's a squared number, and we know 9 is a squared number and difference is the minus sign, right? So we'll factorize this into x minus 3 and x plus 3, which is then equal to 0. And we then know that x is equal to 3 or x is equal to negative 3. Another way of solving for that would be if we have x squared minus 9 is equal to 0, we can just transpose the negative 9 to the right and it would then become x squared is equal to positive 9. And to get rid of the squared, we can just square root, because you know square root and squared are opposite operations, right? And if you square the left, you have to square the right. So this would cancel out this. You'd be left with x. And you know, whenever you square root a number, it always becomes plus or minus. And square root of 9 is 3, which is plus or minus 9. 3. Okay, so now that we have a positive x value and a negative x value, we need, yes? It's the 2015 Gauteng November exam. You're welcome. Okay, so since we've got two values, right, we need to choose one value. So we can see that q is on the positive side of the x-axis and p is on the negative side. So our q value will be positive 3 and our our p value will be negative 3. So we can therefore conclude that our q is positive 3 and 0. Okay, so just clean up this. Okay, so the next question is we did 6.1.2. 6.1.3. Given that x is equal to 4.5 at C, determine the coordinates of R. So if we know that x is equal to 4.5 at C, right? So at S, x is equal to 4.5. So from 0 until S is 4.5 units, right? So OS is equal to 4,5 units. They want us to determine the value of R. So we know that when we deal with turning points, right, and intercepts, the distance from our intercept on the left to our turning point is the same distance from our intercept on the right to our turning point in the middle. So we know that QS is equal to SR. And we know that Q was 3, right? So OQ was equal to 3 units because its x value is 3, right? So all we can do is just take OS minus OQ and say 4.5 minus 3, and we would get our QS value as 1,5 units, right? And then we know that since OS, so the distance from Q to S is equal to 1.5, and the distance from from S until R is the same distance as Q to S, so we know that must also be equal to 1.5. So all we can do is, if this side is equal to 1.5 plus this is equal to 1.5, and from O to Q is 3 units, we can just add them up and say 3 plus 1,5 plus 1,5, and our x value of R would then be 3 plus 1.5 plus 1.5 would then be 6. So we know that our R coordinate would then be 6 and 0. And that another way of calculating it would be to use the distance formula. So if we were to get the distance of Q to S, and since the distance of Q to S is also, since the distance of Q to S is equal to the distance of S to R, we can use the distance formula again if we can't see that it's equal to 1.5, or if we can't do like, if we can't just minus our x values, right? But to be honest, the distance formula is kind of a long way to go. It's much easier to just look at your x values on your Cartesian plane, and like you can just see the x value over here is 0, the x value over here is 3, the x value over here would be, they gave it to us as 4,5, and since this part is equal to this part is equal to this part, we know that from 3 to get to 4.5 is a difference of 1.5. So you just add 1.5 and you'll get to 6. Okay. Guys, please can you mute your mic if you're not asking a question? Okay, so the last question for 6.1 is 6.1.4. So question 6.1.4 says determine the value or values of x for which g of the second derivative of x is greater than 0. So all we can do is we can derive g the first time and then derive it the second time. So our equation of g was g is equal to ax squared plus bx plus c, and then our first derivative would then be, so when we derive, all we do is we say the exponent times the coefficient, so 2 times a, which is 2a, and then we write our base, and then we minus 1 from the exponent. So 2 minus 1 is 1, we can just leave it as x. Then our second part is the exponent of x, which is 1, so we'll say 1 times b, which is b, and then we'll minus 1 from our exponent, so 1 minus 1 is 0, and x to the power 0 is 1, and 1 times b is still b, and we take c as a constant. So when you derive, a constant always becomes 0. Now second derivative, yes, okay. For guys who are struggling with calculus, we'll be doing calculus in our session tomorrow, okay? Okay, let me re-explain. So when you derive, right, so we've got our main equation g of x, which is equal to ax squared plus bx plus c. And when we derive the first time, so when we derive, we take our exponent and multiply it with our coefficient. So the exponent of x is 2 and the coefficient of x is a. So we'll say 2 times a, which is 2a. So that's the first part. We write down 2a. And now we minus 1. So we're going to minus 1 from the exponent. So all we do is, so we minus 1 from the exponent. So 2 minus 1 is 1, and x to the power 1 is the same thing as saying x, right? Now our next part is bx. So when we derive bx, we'll say x, the exponent of x, which is 1, times b, which is b, because 1 times b is b. You write that down. Then we minus 1 from the exponent of x, which is 1, and then minus 1. And 1 minus 1 is 0. So as you know, x to the power 0 is equal to 1. It's actually the same with any number. Any number to the power 0 is always equal to 1. Even if you've got 10 to the power 0, it's equal to 1. If you've got a million to the power 0, it's also equal to 1. So any number to the power 0 is always equal to 1. Okay, so that's why we can just write it as b, because b times 1 is still equal to b. And then we have our c, so plus c. Since c doesn't have an x attached to it, we take it as a constant. So whenever you derive a constant is a number, like for example 2 or 3, or a can be a constant since it doesn't have x, or even pi can be a constant. T can also be a constant because we're deriving x in this case. So all these will be constants. So a constant will just become 0. So you can say plus 0. Okay. So the person who asked to repeat the question, do you understand so far, or is there anything you'd like to ask? Okay. So we have our first derivative as 2ax plus b. Our second derivative would then be, so now we're going to do the exact same thing. We're deriving x. So remember, x now has an exponent of 1. So we say 1 times 2a, which is 2a. And then we minus 1 from the exponent. So 1 minus 1 is 0. X to the power 0 is 1. 2a times 1 is still 2a. And now b is going to be our constant. So b is going to have a value of 0 now, because remember, once you derive a constant, it becomes 0. Sorry, second derivative, right? So now we have our second derivative as 2a. So as we all know, a straight line graph, 2a is then a straight line graph. So a straight line graph would just continue like this. And now they're asking for which value of x, is, when is the second derivative of x greater than 0, right? So our answer to this would then be x an element of real numbers, because for all the x values this graph is greater than 0. If our answer was g second derivative of x is equal to negative 2a, then our graph would look like this. It will be in the negative side, okay? Because remember, this is the same as saying y is equal to negative 2a, okay? So it would be now negative side. But now since the graph is y is equal to 2a, it's now in the positive part of y. And as you can see, a straight line graph continues. Remember, a straight line graph always has a domain of x, an element of real numbers, unless it's restricted. And this graph is not restricted. So to restrict it would mean, for example, if we said 2a restricted between negative 5 and positive 5. So if negative 5 is here and positive 5 is here, our graph would be restricted between this area. So that means our graph would stop here and stop here, okay? But since our graph is not restricted, we can write it as x an element of real numbers. So our final answer here would be x an element of real numbers, since our graph is positive for all values of x, because greater than 0 means positive. So that was the long way of doing this. A shorter way would just be to say, if you have g as a quadratic, our first derivative, so when you derive g, you would get, when you derive g, you would get a straight line. And the derivative of a straight line would then be a constant. Okay, so let's take a practical example as well, maybe to understand better. So if we had a function like this, y is equal to, let's make it x squared plus 3x plus 2, and we derive it the first time. So the first derivative of x would then be equal to, now remember, like I said before, we take our exponent times our coefficient. And remember, the coefficient of x squared is the invisible 1. So we'll have 2 times 1, which is equal to 2. And then we subtract 1 from the exponent. So we'll have 2x to the power 1. And x to the power 1 can also be written as x. Then next, we take our exponent of x, which is 1, and multiply that with our coefficient of x, which is positive 3. And 1 times positive 3 is still positive 3. And remember, now we minus 1 from our exponent. So 1 minus 1 is x to the power 0, which is then equal to 1, and we know 3 times 1 is equal to 3, like we have here. And now remember what I said about constants previously. So when we derive a constant, it becomes 0. So this plus 2 will then just become plus 0, and we can just not write 0 because 0 is nothing, right? Then our second derivative, so we do the same thing. So the exponent of x, which is 1, times the coefficient of x, which is 2. So 2 times 1 is equal to 2, which is equal to 2. And then now we need to subtract 1 from our exponent. So x to the power 1 minus 1 is equal to x to the power 0, which is equal to 1. And 2 times 1 is still equal to 2. And remember, now we have our constant, which is 3. And 3 just becomes plus 0. So now we have our final answer as the second derivative of g of x is equal to 2. Now, do you see what I was talking about before when I said our first equation, which is this equation here, is a quadratic equation. Okay? And then when we derive a quadratic equation, we get this equation right here, which is a straight line equation. And then when you derive a straight line, you just get a constant, which is this. And if you were to see, and if, for example, this was in fact the actual equation of g of x, then our second derivative of g of x would then be 2, which would be like somewhere here. Okay, so I hope the practical example helped your understanding. Okay, so the next question we've got is question 6.2. Okay, so for question 6.2, it says a function defined as y is equal to a x plus p plus q has the following properties. The domain of this function is x an element. Okay, so before we go to that, we can see, remember when I was doing my recap from before, I mentioned that this function over here is the hyperbolic function. So here they've got x plus p. Personally, I prefer to use y is equal to a over x minus p. You can use whichever one you prefer, but personally, I prefer using this one, okay? So this is a hyperbolic function, and it's got its domain as x an element of real numbers except x is not equal to 2. So here we've got our first clue on how to draw this function. So we know that, remember, x is the vertical asymptote. So now we've got our vertical asymptote as x is equal to negative 2. Because remember, the domain is x an element of real numbers except x is not equal to p, and p is the vertical asymptote. So our x is equal to negative 2 is also the same as saying p is equal to negative 2. Second part we have is that this function has got an axis of symmetry y is equal to x plus 6. So from here we can see that this is a positive gradient function, which means it's going to go like this. And if the function, if it's got a positive gradient axis of symmetry, that means it's going to be like this. It's going to look like this. Okay. Because this is the only way to reflect it. If it's got a negative gradient function, if it's got a negative gradient axis of symmetry, so if the axis of symmetry is like this, the function will look like this. Okay. So now, because this one has got a positive gradient function, the hyperbola is in the second quadrant and the fourth quadrant. Okay. So to continue, now that they gave us the axis of symmetry as x plus 6, we can actually calculate our Q value. So remember, this equation is the same as saying, yeah, yeah. Okay, now, so remember before I said when A is positive. Remember, this is A, right? When A is positive, then it looks like this. Okay? But now remember, this is not A. This is the axis of symmetry. It's a different thing. Wait, let me just do a quick explanation about that on the side now. So what I said before was when A is greater than 0, your function will look like this, right? Quadrant 1 and quadrant 3. But because A is positive, it's now going to have a negative, let me use a different color. Okay, so it's going to have a negative gradient as its axis of symmetry. Okay, so this is the axis of symmetry. Axis of symmetry. Okay, which has a negative gradient, which is m less than 0. So when A is positive, the function will be in the first quadrant and the third quadrant, and it will have a negative gradient axis of symmetry, which is y is equal to negative x plus c. And when the function is A is less than 0, okay? So when A is less than 0, it's going to look like this. Your axis, so this is your y-axis, your x-axis, right here. Y and x. Okay, so when A is less than 0, your function is going to be in quadrant 2 and quadrant 4, okay, because A is less than 0. And your axis of symmetry is going to be in quadrant, it's going to have a positive gradient. So now A is less than 0, you're going to have a positive axis gradient, and A greater than 0, you're going to have a negative axis gradient. So your gradient of your axis is greater than 0. Okay, which is y is equal to x plus c. Does that make sense? It's kind of like the opposite. If A is greater than 0, m is less than 0. If A is less than 0, m is greater than 0. Yes? The axis of symmetry, the axis of symmetry never touches the graph. No, the axis of symmetry can't touch the graph, because remember yeah, no, in a hyperbolic function it won't touch the graph, but in a quadratic function it can touch the graph. Okay, so I'll explain both. Let me just start with the hyperbolic first, okay? So in the hyperbolic function, the axis of symmetry won't ever touch the graph, is because it needs to be directly in the middle of it. It can't be too much to the one side. Like, for example, your axis of symmetry can't be here, because then it won't be an axis. Remember, an axis of symmetry. Symmetry is whatever you see on one side has to be identically repeated on the other side. So if you were to fold this paper in, if this was a paper, right, and you were to fold it in half along this line over here. So on this line, you fold the paper, and you make some ink marks over here. Okay, Once you fold the paper, that exact same ink marks must occupy this exact same space, just on the opposite side. Okay? And it's the same with this one here when a is greater than 0. Does that make sense?
Yes, it does.
Okay, so then with the quadratic function, I don't think I did axis of symmetry with quadratic during my recap. Okay, so with the quadratic function, okay, so you've got your quadratic function. Let's make it a smiley face one. Okay, so your quadratic function is a smiley face, which means a is greater than 0. So now when you find the axis of symmetry of the quadratic graph, you can't really have a horizontal axis of symmetry. What I mean by that is, for example, if this is your graph, right? And your axis of symmetry, if this is your axis of symmetry, that won't work, because if you were to fold the page on this green line, can you see what's at the bottom over here won't be at the top, because it looks different as compared to if you were to have an axis of symmetry, a vertical axis of symmetry. So if you were to fold your paper, if you were to fold your paper down this line over here, can you see what is on the left would be identical to what is on the right? So that's why when you're dealing with a quadratic graph, and it's either a smiley face or it can work with the sad face, your line of symmetry will always be a vertical line of symmetry. So let's try it out with the sad face graph. Can you see your axis of symmetry would always still be the same, a vertical line? So with a quadratic graph, your axis of symmetry is always represented as x is equal to the x value of your turning point. So for example, if this point over here, actually, where's our graph here? Okay, so if our if our turning point is here, right? And say this value is -5 and x would be 0 here because it's on the axis. So x would be 0 and say y would be -10, okay? So your axis, and the question asks you, for example, what is the axis of symmetry of f? So your answer would then be x is equal to 0, and that's all that you do, and you'd get your, if it's 1 mark or 2 marks, because all you do is remember the axis of symmetry is x is equal to the x value of the turning point, and as you can see here, the turning point is 0. If maybe the turning point was like 2 and 6 for any graph, your axis of symmetry would then be x is equal to 2. Okay, so whoever asked the axis of symmetry question, are you okay with the explanation, or is there anything else you still don't understand? Okay, so okay, you're welcome. Let's get back to our question. Yes, you were saying?
So it says here that the domain is x. And then what are you saying?
Yeah. Okay, so remember I said the gradient of the axis of symmetry is positive, but the hyperbolic function itself has a negative a value, because remember when get my pen. Okay, so remember when a is greater than 0, it's represented in the first and third quadrant, and when a is less than 0, it's represented in the second and the fourth quadrant, like this over here. So can you see what we did was second and fourth quadrant, which means it has a negative value of a. But can you see the axis of symmetry? It's a positive gradient, right? It has a positive gradient of m greater than 0. So like I said before, whenever a is less than 0, the gradient of your axis of symmetry is going to be positive. And whenever a is greater than 0, your axis of the gradient of your axis of symmetry is going to be negative. It's always the opposite. You can't have a positive axis of symmetry, a positive gradient for your axis of symmetry, and a negative, and a positive a value. Whenever your a value is positive, your gradient for your axis of symmetry will be negative. Whenever your a value is negative, the gradient for the axis of symmetry will be positive. Does that make sense? It's always opposite. So this will have a positive gradient for its axis of symmetry, and this will have a negative gradient for the axis of symmetry. So m less than 0. Okay. Okay, cool. Can we move on to the question paper, or is there anything anyone else would like to ask? Yeah. Okay, so they give you the positive axis of symmetry because they asked you to sketch the graph, right? And they didn't give you an actual function where you can put it in your calculator and get each coordinate. They just gave you like hints in order to sketch it. So because they said that, wait, let me just get my pen. Because they said that it's got a positive axis of symmetry. And remember, like I said before, whenever it's got a positive axis of symmetry, you use a negative a. And remember, whenever a is negative, it's always in the second and the fourth quadrant. So in order to sketch the graph, we need to know which quadrants it's in. And because they gave us this information, it helps us get the quadrant, and this information will also help us get our Q value, which is our horizontal asymptote. Does that answer your question? Okay, so can we continue, or does anyone else want to ask a question? Okay, so I'm gonna continue. Sorry, you were saying? The last what?
Bullet.
The last bullet, yeah, I'm gonna get to that. I need to first finish up with the second bullet. We weren't done with that. Okay, so to continue now. So we have our axis of symmetry as y is equal to x plus 6, right? So now from this, we can actually calculate our q value, which is our horizontal asymptote, right? Because we have our vertical asymptote, which is p is equal to -2. Now we can calculate our horizontal. So remember, y is the same as saying q, because remember, y is equal to q. So we can have q is equal to, and our x value, they already gave us our x value as -2. So we can say q is equal to -2 plus 6, and therefore Q is equal to positive 4. So now we have our vertical asymptote, we have our horizontal asymptote, and we have which quadrants the graph is going to occupy. So now to move on to the third bullet point, okay, just give me a second to neaten this up so we have some space. Okay, so we have x is equal to -2 and q is equal to 4. And we have our quadrants. Now our third bullet point, the function is increasing for all x an element of real numbers where x is not equal to 2. So now they say that the function is an increasing function. So remember I explained increasing and decreasing functions before when I did my recap. So an increasing function, for example, if you've got a function, let's use a straight line function, right? If you've got a straight line function, right, you can see that this is an increasing function because as the graph, you start off from the left, okay? So as the graph goes from the left, it's all the negative values. And as it goes towards the right, it becomes positive values, which means it's increasing. So as the x values are increasing, the y values as well are increasing. So here you've got a negative in this part, right? You've got negative x values and negative y values. But as you go to the right, you get positive y values and positive x values. So you can see that as the graph moves towards the right, the x values increase and the y values increase. So if both x value and y values are increasing as the graph moves towards the right, you say that that is an increasing function. And a decreasing function would be, so if you've got your function like this, now you always, when you're dealing with increasing and decreasing functions, you always start from the left and go to the right. So here you can see that the graph has got positive x values and positive y values on the left, and on the right it's got negative y values and positive x values. So as the graph moves from the left to the right, the x values are increasing, right? And as the graph moves from the left to the right, the y values are decreasing. So because x values are increasing and y values are decreasing, this is known as a decreasing function. But if both the x and y values were increasing, it would be known as a increasing function. Let's do increasing and decreasing functions for hyperbolic functions, since that is what we're dealing with, and then we can get back to the question. So you've got your axis of symmetry. Got your function. Okay, so now let's start with the one on the left. Okay, so the one on the left, you can see that as the graph goes to the right, the x values are increasing. So the x values, they are increasing, right? And the y values are also increasing, because you can see as it's going to the right, can you see all the y values are positive? So it went from negative y values to positive y values, because in quadrant 3 the y values for this graph are negative, in quadrant 1 the y values are positive. So negative y values and positive y values, which means as the graph goes from the left to the right, the x values are increasing, and as the graph moves from the left to the right, the y values are increasing, which means that it's a sorry, you were saying? Oh wait, sorry, I made a mistake here. The y values are decreasing, sorry. Sorry about that. Sorry. Yeah. So as it's going to the left, you can see that the y values are decreasing, right? Decreasing. Which means that this is a decreasing function, right? Because as you move, if you take it from the left, right, you can see from the left, you can see the y values are dropping. It's becoming more and more negative, which means it's decreasing, right? So this will be a decreasing function, right? Decreasing function. And then the one now on the right. So as you move from the left to the right, but okay, for x, right, as long as you move from left to right, your x values will always increase. Okay, it's only the y values that you have to like see whether it's increasing or decreasing to find out whether it's an increasing or decreasing function. So as you move from left to right, your x values will always decrease, because you know on the left you've got your negative x values, and on the right you've got your positive x values. So as you move from the left to the right, your x values are increasing, and your y values. So as you can see here, right, your y values, say for example, if this is maybe like 1, this is 2, and this is 3, right? So as you can see, it's getting bigger, right? As you move from the left, it's increasing, it's increasing, it's increasing from 1, 2, 3 until wherever it goes, until infinity, right? So then you can see your y values are increasing. So your y values are also increasing. So because both x values and y values are increasing, this is called a increasing function, right? So does anyone have questions on the increasing and decreasing function before we move on to the question? Okay, so I'm going to move on, right? So now to get back to the question, draw a neat sketch graph of this function. Your sketch must include the asymptotes, if any. So we can start with our x and y axis. So this is our y-axis, this is our x-axis, this is our 0 point. Okay. So before we start, we need to first plot our asymptotes, right? So we remember our x asymptote is -2, our q asymptote is, sorry, this should be p. So our p asymptote is -2, which is the horizontal asymptote, right? So -2, we can have it somewhere here. And then our q, which is our horizontal asymptote, we can have it here. So we'll label this asymptote first. P is equal to -2. And then our q asymptote, q is equal to 4, which is our horizontal asymptote. We can have, let's make it a different color. We can have +4 somewhere here. And q is equal to 4. Okay, so let's actually extend our axis for this. Here. Okay, so remember before we calculated our value of q using our straight line axis of symmetry. So we had, let me explain that again. So we had y is equal to x plus 6, right? This is our axis of symmetry. And remember, y is the same as saying q, right? Because q is equal to y and x is equal to p. So y is the value of q, so you can substitute q into there, is equal to x. Now remember, our x value is -2, okay? Because they gave it to us in the question. -2 plus 6. So therefore q is then equal to +4. Do you understand?
Yes, sir.
Okay. Do you have any other questions regarding q or anything else? Okay. So let's continue. Okay, so we extended our axis of symmetry, right? I'm sorry, our y-axis. So we extended our y-axis to the top. Now we can, let's extend our p as well. Okay, so this is our axis. Let's extend this as well. Actually, not. Let me just redraw. This looks like a mess. Okay, sorry about that, guys. Okay, back to our axis, right? So we've got our y-axis and our x-axis. So this is y, this is x. We've got our vertical asymptote at -2, which is x is equal to -2, and remember x is our p value. X is -2. Then we've got our horizontal asymptote at +4, and remember our horizontal asymptote is our q value, which we calculated using the equation of our axis of symmetry equation, and q is equal to 4. So our graph is then going to look like this. So remember, our graph can't touch -2 and it can't touch +4. So it basically can't touch any of the axis of symmetry. So we sketch our graph like this. Okay. And in this quadrant, it's going to be like this. Okay. So does everyone understand how the graph came about? Is everyone okay before we move on to the next question?
Yes, sir.
Okay. So let's try and do one more question before time finishes. In our first question, we did what exponential graph. In second question, we did quadratic graph and hyperbolic, right? We covered majority, and we did linear in the second, so we should have covered all, right? Let's see, what is this question about? This is about a quadratic function. This is an exponential function. That's quadratic and exponential. And this is hyperbolic only. And this one was, what was this again? And that's quadratic and hyperbolic. So which one do you guys want to do the hyperbolic and quadratic, the hyperbolic on its own, the exponential, or the, I think that was quadratic. Before time finishes up. Exponential. Okay. Okay, so majority of you guys want to do hyperbola and quadratic. Okay, let's start with that then. Okay, so the hyperbola and quadratic function, right? I think this is, wait, let me try and remember how I set it up. So this was 2015, 2016, and I think this is also 2016. Okay. So for those of you who want to know what question paper this is, I think this is the 2016 Gauteng paper, if I'm not mistaken. Is the question visible for everyone? Okay, so let's get started. Excuse me? It's visible for everyone. Okay, let me see if I can zoom in. And how about that? Is it fine for everyone? Okay. So, again, for anyone who didn't hear, this is the 2016 November Gauteng paper. Okay. Okay, so it says sketched below is the parabola f with equation f of x is equal to negative x squared plus 4x minus 3. So this is a sad face parabola with a less than 0. Okay, so and a hyperbola g with equation x minus p and y plus t is equal to 3. Then they say B, the turning point of f, lies at the point of intersection of the asymptotes of G. So the vertical and horizontal asymptotes of G are intersecting at the turning point of that graph, of our quadratic graph, which is right here. Okay. Then it says A is negative 1 and 0. So where's A? Okay. The x-intercept of the hyperbolic graph is negative 1 and 0. So our first question says, show that the coordinates of B are 2 and positive 1. Okay, so let's get started with that. So question 5.1. So show that the coordinates of B are 2 and 1. So first of all, we can see that B is actually the turning point of our quadratic graph, right? So if you guys remember from my recap, how to calculate your turning point is the x coordinate of your turning point is equal to negative b all over 2a. And as you can see, the b value of this function is positive 4. So it's going to be positive 4 in the brackets all over 2, open a new bracket, and our a value. So as you can see here, our a value is negative 1. For those of you guys who don't know, a is the coefficient of x squared, b is the coefficient of x, and c is the remaining constant. Okay, so now we have our x value of our turning point as negative 4 divided by negative 2 is positive 2. So after we find our x value, now what we need to do is substitute this x value into the original equation to find our y value. So y is equal to negative, open a bracket, 2 squared plus 4, open a bracket, 2 minus 3. And 2 squared is 4, that's going to be negative 4 plus that's going to be 8 because 4 times 2 is 8 minus 3. So we know our y value is equal to negative 4 plus 8 is going to be positive 4. Positive 4 minus 3 is positive 1. So now we have our x value, we have our y value, and we have p as 2 and 1, which is what the question asked us to prove. Okay. Now moving on to the second question. Oh, I forgot about this logo. Sorry guys, just give me a second please. Okay. So question 5.2. Question 5.2. So question 5.2 says write down the range of f. So as you guys remember from my recap, how to calculate the range of a quadratic function is y is less than, or if it's a less than 0, or y is greater than if it's a greater than 0. So remember, if it's a greater than 0, it's going to be a smiley face. And our range is therefore y greater than or equal to the y value of your turning point. And if it's a sad face graph, it's going to be y less than or equal to the y value of your turning point. And since this is a sad face graph, we're going to go with the y less than or equal to. And remember from our previous question where we calculated the y value of our turning point, which is positive 1, our range is therefore going to be y less than or y equal to positive 1. Okay, so that means that the graph of f touches all the y values from positive 1 all the way down to negative infinity. This can also be written as y an element of positive 1. So we use square brackets since we're including our 1 value. If we were not including our one value, we would use round brackets. So for example, if it was y less than 1, we would have a round bracket by 1. Okay, so now since we including 1, we have square brackets. So our range is going from positive 1 all the way down to negative infinity. And whenever you're dealing with infinity, whether it's positive or negative infinity, it's always going to be represented with a rounded bracket. Okay, sorry, did someone have a question? Oh yeah, sorry, yeah, it's the opposite way around. Yeah, sorry. Sorry about that, guys. So it is going to be from negative infinity to positive 1. Sorry about that. Yeah, so it's going to be from negative infinity all the way to positive 1. So our graph touches all the y values between that range. Okay, and the domain of this graph would then be x an element of real numbers, because the graph would touch all the x values. Okay, so moving on to the next question, 5.3. We've got, for which value or values of x will g of x be greater than 0. So g of x is the hyperbolic function, right? So in order to be greater than or equal to 0, you have to be equal to 0 or positive, right? So the question is asking for which values of x is the graph positive, okay? So we know on our left side of the equation our graph is negative, and on our right side of the equation, on the right side of the asymptote, our graph is positive, because here you can see, okay, until this point all the values are negative below that point, and above the point all the values are positive. So I'll just clear this up. So the only values that are positive is this part over here and this part over here, because as you can see from point A the graph becomes positive, right? So when we answer this question, we're going to have an inequality, and we're going to have, sorry, when we answer this question, we're going to have an inequality, and we're going to represent this part of the equation, and we're going to represent all the values on the left of -1. So let's start with the -1 part. So when we answer this question, we'll just say x less than or equal to -1, and we can say x greater than, and remember we calculated this line before in question 5.1. It was the turning point of B, and it had an x value of 2. So our answer is going to be x greater than 2. We can't say x greater than or equal to 2 because remember this graph cannot touch 2. So we're not including the value of 2. Okay, so we always say x greater than 2. And here we used less than or equal to because on this point x is equal to 0. And remember the graph said greater than or equal to 0. So that's why we included this point over here. So our final answer is x less than or equal to -1 or x greater than 2. And another way of representing this would be x, an element of real numbers from -infinity all the way to -1, and we have our square brackets because we're including 1. And we can have, and sorry, you were saying? I'm sorry, I didn't. Would you be able to repeat your question, please? No, it's -1. Okay, let me zoom in for you guys to see. So can you guys see that we're using this value here, right? We're not talking about the horizontal asymptote. Right now we're seeing which values of x in the graph of g is greater than or equal to 0. So remember I explained before that everything below the y-axis is considered less than 0, is negative, and everything above the horizontal axis, our y-axis, is considered positive. So can you see, let me just get out the pen. So can you see from here until this part here, that's everything that's below the y-axis, which means it's negative. And okay, on the right we don't have anything up below the y-axis for g, right? So it's only this part here that's below the y-axis. But can you see the part on top, the part that's highlighted in green? Sorry, the part that's highlighted in red. Can you see that part starts at -1 and extends? And the arrow indicates that it's continuing, it's extending all the way until -infinity. Then can you see this part here that starts here and continues? Sorry, it doesn't start there, it just continues going upwards. So this thing will continue going up until positive infinity. This will continue to go right until positive infinity. But under no circumstances will this g function ever touch this asymptote. So it's never going to touch this line here. Does that make sense? It can come close to the line, but it's never ever going to touch the line. That's why we say x greater than 2 here, meaning from 2 all the values to the right. And here we say x less than or equal to -1 because it's all the values from -1 inclusive of -1 all the way to -infinity on the left. So does that answer your question, or is there anything else that you'd like to ask? It does. Okay, welcome. So let's get back to the question. Okay, so back to our answer. The second way we can write it is x an element from -infinity to -1 inclusive of -1 and x an element of +2 until positive infinity. Why we don't write a square bracket for 2 is because we're not including the value of 2. Remember, 2 is the vertical asymptote and the graph can never touch 2. That's why it's a rounded brackets, okay? And positive infinity and negative infinity are always rounded brackets, okay? Okay, the next question is question 5.4. So question 5.4. Determine the equation of the vertical asymptote of the graph of h if h of x is equal to g of x plus 4. So now we need to find the vertical asymptote. Remember, the vertical asymptote is our x asymptote, which is also p. The vertical asymptote is this one over here, the one that cuts the x-axis, the one that I just highlighted in red, okay? So that's the vertical asymptote. We need to find the vertical asymptote of h, and h is equal to our graph of g plus 4 units. So it's going to be shifted 4 units to the right, okay? So therefore we know that we can just take our asymptote of g, which is x is equal to 2, and since this graph is shifted 4 units to the right, we just say plus 4, and our x asymptote of h is then equal to 6. Okay, so all we're doing is we're shifting our x asymptote 4 units to the right. So for example, if this is, let's see, if this is 6, we're just shifting this 4 units to the right, and it would end up here by x is equal to 6, and that would be the asymptote of h. Okay, now for the next question, we've got determine the values of p. Yes. Oh yeah, just sorry. I'll always get sleepy towards the end of our sessions, as you saw yesterday as well. Okay, sorry about that, guys. Question 5.4, right? So if G shifted to the left, it's going to then be x is equal to 2 minus 4. So if we have our 6 here, sorry, negative 6, our graph is going to go, our asymptote is going to go from there all the way to there, shifted 4 units, right? So therefore our x value is going to then be x is equal to 2 minus 4 is negative 2. Okay, shit, why did I put x on 6? Okay, so all we do is we shift our graph 4 units to the left. Now for the next question, question 5.5, says determine the values of p and of t, right? So if we're going to determine the values of p and of t, we're going to use our G equation, our hyperbolic equation that was given to us in the question, which is x minus p and y plus t is then equal to 3. Okay, so from there we can just try and simplify the equation and write it in our standard form, which is y is equal to a over x minus p plus q. So in order to do this, we need to get y on the left. So we can divide by what's not y, which is our x minus p, because we need that to be on the right. So from there, we'll have y plus t is equal to 3 over x minus p. Then after that, we can see that we've got y plus t on the left, so we need to get rid of the t. So we can transpose the t to the right side of the equation, and we would then have y is equal to 3 over x minus p minus t. Okay, and now our equation is written in standard form. So back to the question, they asked us to determine the values of p and of t. So what we can do is, remember, p and t are both asymptotes, right? So p is our vertical asymptote and t is our horizontal asymptote. So from our first question, we dealt with our vertical asymptote, which was positive 2. X is equal to p is equal to positive 2. So we know that our p value is then positive 2, right? So from there we can get a p value of positive 2. So if we wanted to substitute it into here, we can just put blue. We can just put our positive 2 value there. And now to find our t value. So in order to find our t value, all we can do is we can substitute our So in order to find our t value, all we can do is we can take this, where's my pen? Okay. So we can take this negative t and equate it to, actually they didn't give us our horizontal asymptote, so we can't actually do that. So the next best thing would be to substitute our point that they gave us, which is a. So we can substitute our point a into our equation and actually solve for t. So remember, a was negative 1 and 0. So this is the x value and this is the y value. So our y value is equal to 0 and our x value is equal to -1 minus 2 minus t. From there we can take t to the other side. It will then become positive t, which is then equal to, this will become -3. So 3 over -3 is then equal to -1. So our t value is equal to -1. And if you want to write out the equation again in standard form, you can just write it as y is equal to 3 over x minus 2, and negative, open a bracket, -1 is then +1, right? So you can just rewrite it as +1. So before we move on, did everyone understand that part though? Yeah. Yeah, you could have actually done that as well. Oh yeah, they did give us our horizontal asymptote, right? It was 1, if I'm not mistaken, because it's a value of b. So if you want to use that, okay, let me just clean up. So if you want to use that, right, you could have just said, okay, so we started with p is equal to 2 from our xb value, and then using our b point again. So remember we had our equation as y, so we had it as y is equal to, what was it, y was equal to 3 over x minus p minus t. Yeah, so remember this is our horizontal asymptote, right? And they said our horizontal asymptote is the y value of b, which is +1. So if you say negative t is equal to +1, you divide by -1 on both sides, and you then get t equal to -1, because +1 divided by -1 is -1. So then we have our p value and we have our t value. Does that answer your question? Okay, so there's two ways of calculating that. So the last question, write down the values of x for which for which f times g is greater than or equal to 0. So now in this question they want us to find the values of x for which, when we multiply our quadratic graph times our hyperbolic graph, it must give us a positive value, because remember, greater than or equal to 0 is a positive value. So in order to get a positive value,
Can you please
enlarge the question. You can see the derivative.
Yeah, can you please?
Okay. Is that better? Is everyone able to see the question clearly? Okay. So remember we need f. Where's my pen? Shit. Okay. So we need to have f times g is equal to a positive value, right? So how do we get a positive value? We can say negative times a negative, and that can give us a positive value. Or we can have positive times a positive, and that can give us a positive value. So we need to see when is both f and both g negative at the same time, or positive at the same time, right? They can't be one positive, one negative, or one negative, one positive. They both have to be either positive at the same time or negative at the same time. So what we can do is, let's see, go back to our graph. Okay, let's start with looking for when both are negative at the same time, right? So both are negative at the same time here. So as you can see, G is negative and F is negative. But remember, we can't use this greater than 2, right? All the values on this side as negative. Because remember, as you can see here, F is negative, but G is positive. So that's not going to work, right? We need them both to be either negative or both to be positive. Actually, it's only negative until here, okay? Sorry, you were saying? Wait, let me zoom in, sorry. Oh yeah, you are right. It is the derivative of G. Sorry, I didn't see that. Okay, so when it's the derivative of G, right? So we know that G is a hyperbolic function, right? So when we derive G, all we can do is, let me make some space. Can everyone still see the question?
Yeah.
And now is everyone able to see clearly? Okay. Okay, so it's F times the derivative of G must give us a positive value, right? So when we multiply, F has to be positive and the derivative of G has to be positive to give us a positive value, or they both need to be negative. So when we derive for G, right, all we can do is we can use the x-intercepts of both. So to use that, all we can do is what is this? Negative x plus 4x minus 3 is equal to 0. So this is the graph of F. Let me use different colors for both. Okay, so let's make the derivative of G blue, right? So our F graph is red. So all we can do here is we can write it in standard form and we can take out the negative to do that. So it's going to be x squared minus 4x plus 3 is then equal to 0. And we can factorize this. So we need to have factors of positive 3 that give us negative 1. So we can use negative 3 and, they give us negative 4. So we can use negative 3 and negative 1. So x is equal to 3 or x is equal to positive 1. Okay, that's the first part for our f function. Now to start with the derivative of g. So to get the derivative of g, we know that the derivative of g for x an element of real numbers where x is not equal to 2 is less than 0, right? So what is this? X 2 is over here. Sorry, said we're going to use blue. Okay, so our x equals 2 is this point over here. Okay, so our derivative is less than 0 for x an element of real numbers where x is not equal to 2. So for all the values of x except x is equal to 2, the derivative of g is less than 0, right? So then we can write it g prime less than 0 for our domain, right, of g, an element of real numbers where x is not equal to 2. From there, we know that f is also less than 0. So from there, we can then conclude that x is less than or equal to 1, or x is greater than or equal to, wait, this is coming out funny, or x is greater than or equal to 3. Alternatively, we can write it as negative infinity. Since we're inclusive of 1, we have it as square brackets union 3 to positive infinity. Okay? Guys, I'm tired now, and it's already past our 7 o'clock time. So tomorrow we're going to have calculus from 5 till 7. And you guys have the timetable, right? So tomorrow is calculus from 5 to 7, and our admin guys are going to post the videos on our website for you guys to download later on and rewatch them in case you need to. And on Saturday and Sunday, our times are going to be different. It's going to be from 3 to 5, okay? So whoever's going to show up tomorrow, I'll see you guys tomorrow. Okay, I'm really tired now. So bye everyone, and thank you for coming. Bye. Why is this not ending now?